Oh, hello everyone. It's February 12th. All right. We have another easy one today, so it'll be good because we need to fight this thing again. Actually, I didn't find a good solution yesterday. Was the bug happens when we have the same number of digits. That was the bug. This is the piece of code we need to fix. But so far, nothing yet. I mean, yesterday was a bit rushed at the end, so we just have to deal with it. And it's actually more complicated than that, right? It's more complicated than that. What we need to do, I mean, this part I think is fine. This part is to find everything in between, right? Find everything in between. But what is difficult is to get the edge cases. I mean, this edge case is when the two things are different, right? They have different lengths. But if they have the same length, things can get very, very tricky, right? Very tricky. Yeah, we have to really think hard on this. I mean, the general idea is right. Like, this is correct. It's just to handle that edge case. But anyway, we're gonna try to do this first. Find first palindrome again? It's like, I don't know how many times have we done palindrome today, this week. Return the first palindromic string in the array. Oh, the first palindrome. I'm okay. It's more of a test of how you're gonna program it than actually the program itself. Yeah. So many things that I need to do, and I kind of, didn't really. I mean, over the weekend, have to handle a lot of other things. What the plan was to get the debugger set up, but we still haven't set up the debugger, which is very sad, but that's okay. All right, basically we're gonna just check palindrome. Is palindrome. We're gonna passing a string. We can say a word. All right. Okay, so one way to check is palindrome is we did this before. Check palindrome, right? So int I 0 int j equals word out length. Okay. Well, actually, length -1. And I say while I smaller than j. Oh, j. Right. If word.char@, I is not equal to word.char@, j, then we'll return false. Okay. Otherwise, after we're done, we'll return true. All right, and then what we need to do is for string w of words, if is palindrome w, return w, otherwise return. Okay, that should be fairly straightforward. Oh, shoot. I forgot I++. Ooh, interesting. Plus plus, minus minus. Right, I++ is a return a value and then plus, right? Oh, I've done this before. Oh, hold on, that's not right. Two, 1, 8. All right, so we're done with this. We're gonna move on. All right, let's get back to that. This one. So what we are struggling, basically, is when the two are the same. So we probably can get some examples. You know, not like this one, but like this one. Uh-oh, this one's correct. What was the... Oh, we fixed this one, but another one has failed. Oh yeah, we fixed this one, but we have other things. I don't know, like just random. I was trying to see if any. Nah, this is not gonna work. When they're the same. Hold on, just kind of think, right? Just kind of think what will make it wrong. We do count the edge case is we're trying to find the number of stepping with the same starting digit. Oh, I see, like maybe, no, 29. Oh, that's like 11 to 10 to 19. Yeah. So when this happens, right, what we did is I have 10 and 12. How did I get 4? Ah, because I counted twice. I did edge on the left and did edge on the right. That's what it's wrong. So we need to handle it better, right? So one way to do is, you know, if I put this down here, right? So they're not the same. So we know we need to count the edge cases for sure, right? We know we count the edge cases for sure. But when they are the same, right? When they are the same, then what we need to do is starting from the first, the low, right? Yeah, how do we... Well, it depends, right? It also depends on whether the two yo, this is a bit complicated. So they're the same, right? And well, if the first one, they're different by count edge, probably the low and high, just to make sure that everything will be fine. So maybe we can make some changes, you know. We should do it here, but count edge, I mean, we have low and high, right? We have low and high, and then we just want to count is low, right? Okay, so we have low and high, and if it's low, right? So what we need to see is if, as we go, you know, something gets too big, it goes beyond the high, then that's a no-go, right? And if we decrease, but we still have we run the risk of doing it twice, right? We run the risk of doing it twice. Okay, hold a second. No, we have edge. So it's very clear that if the two have the same length, and the low, the starting position, and the high starting position are different, right? If they're different, and what we do here is function returns the count of stepping numbers with the same starting digit, which means if the two have different starting digit, then we should be fine, right? So in this case, if they're the same, right? If they're the same, then we shall, find the first one that are different and then do, right? From the first one that are different, and then we do those, right? We do those for the county edge. And if the two have different size, then we don't really care. Which means I think what I'm going to do, I'll move this one here for sure. Actually, no, we're going to move this one here. Right? So we're going to move this one here. And for here, if the two are the same, yeah, that's a tricky one. If the two are the same, then what we need to do is to have an index is 0. Okay, so while low index is equal to high index, okay, index plus equal 1, right? And now we don't do this, don't do this. We have to also say while index is smaller than low, and this, right? We do all that, and once we finish, then we need to say res shall equal to well, it depends, right? We say if index is equal to low, that means the two are the same, then we just return. So the two are the same. Ooh, the two are the same. The two are the same. Well, it depends on whether the current value is. Holy crap. Holy crap. Well, if the two, like if the starts is different, then we can run the count edge cases to count, right? But if they start to be the same, right? They start to be the same, then whenever they are different, because they have the same, right? And if the first one's the same, then we check the second one, right? And the second one, oh, how do I handle this? Like they have the same length, right? They have the same length, and what if the first one is different? They still run the risk. Yeah, because we only care about the first one, right? We care about the first one. So the first one, if they're different, then we check You know what? If the first one's different, then there's no chance of them overlapping. Yeah, if the first one's different, it will be fine. Because we don't, yeah, if the first one's different, it'll be fine. It's only when the first one is the same, the second one is the same, and the third one is the same. And as we move on, then yeah, then it will be impossible, right? Then it will be impossible because if the first one is the same, right, and the second one is also the first one is the same, then we check the second one, right? And the second one is not the same. Then, yeah, then what do we do? In fact, I'm pretty sure this shall be if these two are the same and low 0 is equal to high 0. That's the only case. Right? We only will come into this if that happens. If the two are the different values, it's not going to happen. We can definitely work it out. It's when the two are the same and the first value are the same. Then we have this issue. Right? When the first values are the same, then on the second one, we have to deal with it, right? We have to deal with it. So the second one, for the low, I shall only increase, right? Yeah, I shall only increase for the high. So for the low, if I increase, I need to compare to the high to make sure that it's within the range, right? You make sure it's within the range. How should I say it? Right, if the first one is the same, then we check in the second one. Then wait, hold a second. If the first one is the same, they only have the same one. There's no other way. There's only one set of values that can handle it, which means I shall have another function to do this specific, right? To do this very specific case. It's a very specific case. We have a low and a high at first, and then we have to check both, right? We have to check both because it starts with the same one. Therefore, when this, I probably have, so count edge case, right? Well, let me do another def count edge count count edge case. This is count also edge case, right? Count edge case. Oh. Both. Okay, count edge case both. And yeah, say this one, this function counts the number of step-in numbers between low and high when low and high have the same number of digits and the same digit, the same first digit. Okay, so in this case we have a q again, that will be int low 0. Okay, and then we do say index is 0, count is 0, while q and index smaller than low. Right, temp, it's the same thing, but for d in q, current equals int current low, right? Current low is int low index current high is equals to int high index, right? And now we say if d is equal to low, current low, and equal to current high, right? If the two are the same, then if d is larger than 0, temp dot append d minus 1. If d is smaller than 9, temp dot append d plus 1. Okay, that's it. All right, next one. If d is, if current low is smaller than d, smaller than current high, right? If current low is in between the two, well, it could be if it's equal to low and it's smaller than, hold on. So we have like different situation. It could be, you know, smaller equal to low and a smaller equal to high, right? Well, the reason is if it's equal to, then we need to check the next, right? So if it's equal to low and equal to high, right, then we will check the next. So the next one, if it's equal and equal, so whenever it's equal to the current low and current high, then we throw the next one. And then in the next one, if it's in between, right, then we know this one will work. Then we run the count. If it's equal to something, but it's smaller than the other thing, right? If it's equal to something, but it's smaller than the other thing, like it's still within, but it's inclusive on one side. If you're inclusive on one side, so like if it's 2 and the other one's 3, so that is actually might not work because you have to make sure to keep going. So if it's equal to one of them, right, then you have to always try it. Okay, so hold on. So if it's equal to low or is equal to high, right? If it's equal to low or it's equal to high. So when it's equal to low, would it be possible it's equal to low? So the first one definitely will be equal, right? And then I'll throw two things, right? If they're equal, I'll get a small one coming in and I'll get a bigger one coming in. And if the next one is, what if it's equal to high, right? It could be larger than low, but it's equal to high. And we cannot keep working it, right? We cannot keep working it. So what I think is, shoot, do we need, like, because we're developing this, because each one has to satisfy, right? Because we start with the equal and then we jump to the next one, right? And the next one, as long as it violates one of them, right? If you violate one of them, then you're gone, right? If it's smaller than a low or if it's bigger than a high, you're gone. And if you're still within range, right? If you're still within range, then you're good. If you are equal on one of them, but not equal on the other side, then it becomes the same case, right? It becomes the same case as count edge case, right? It becomes the same case as count edge case because it is good on the other side. So, okay. So both are equal, we do this. If, actually, we didn't do elif, right? Elif this, then count plus equal to dp, d, len, low, minus index. Done. This one is just satisfy both. Elif current low is equal to d, and d is smaller than current high. Right, so d is smaller than current high, but d is equal to low. In that case, count shall plus equal to will definitely satisfy the high, right? We definitely satisfy the high, but we do not know about the low. So in this case, what we do is we say we'll do count edge case, okay? Low index towards the end is low is true, right? Because it's the same. So what we need to do is from the current to the end, we just throw it into the count edge case. Again, elif current low is smaller than d, and d is equal to current high. So in that case, we'll definitely satisfy the low. So count plus equal to count edge case high index towards the end, right? And then false, right? High is the current one. From index towards the end, we try to find high, right? And else, if none of this satisfies, then that's it. So as we go through, we say q equal to temp, index plus equal 1. And at the end, we do the same thing. If index is equal to len low and q, then count plus equal 1. Now return count. So if that's the case, we basically don't do any of this, right? We say we return count edge case both. We just count edge case both. Else, that means it can be equal, but if the first one's different, then we don't really care, right? We don't really care. Actually, right? Otherwise, I should do this. What do you think? Then we're wasting, right? We're wasting this call on this. You know what? Let's not do this. Okay. So we say if the length is the same and if the first one is the same, we use this very special case, right? We use this very special case. And if the first one is not the same, then we are pretty confident we can run the count edge case on both of them. And then I go from low all the way now reach high to handle everything, and that's it. Otherwise, we do the edge case and we do count the rest the same number of digits, yes. And then we do this one and then we do this one. Okay. So this is kind of another solution. Okay, there's a bunch of print. Okay, we have some, this one. We have another print. We do have another print. Okay, so these are good. Let's run this. Okay, let's try it again. Oh, all right. Experience some a little bit hard on this. Huh. Yeah, the basic idea is to use DP to find the number of stepping numbers, right? Given the first digit and the length of the number, and the total number of digits, and the total number of digits. For example, VP 35 is equal to the number of stepping stones, numbers starting with 3 and having 5 digits. Then we break down the problem into finding all the stepping numbers with the same starting digit as low and same length. Finding the stepping numbers with the same starting digit as high and same length. And then finding all the stepping numbers in between. Now the tricky part, right? The tricky part is when low and high have the same number of digits and the same first digit, right? I used a separate function to handle that scenario. I mean, other than that, it's pretty straightforward, right? Other than that, it's pretty straightforward. And or, let's check both. Runtime mainly is just the DP part. I think other than the DP part, it's pretty straightforward. And the DP will take, this is a 0 to 10. 10 times num digits, right? 10 times num digits for that. And the way we do it, and this will go through, again, 10 times num digit, right? So I call it O 10 times num digit for this, and 10 times num digit. And how about these? It's like 10 times as well. So it's actually hard to say. Maybe 10 times 10 times len high. That's kind of my way of handling this. Okay. Done. Count. All right, and I'll try to see how this one is done. The DP is to count number of stepping numbers in range 0 towards n. So count high minus count low. That's an interesting idea. What's tight? Found a good number. Max digit if tight. Zero is tight. And a leading zero. Max digit. Next tight. Tight and D equals to max digit. So if original is a tight and D is equal to the max digit, what is this max digit? The max I can go? The max digit. So how far I can go, I think, right? It's how far I can go. That doesn't make any sense. Max digit. I don't understand. From 0 to n. Okay, how many stepping numbers? So we say all the way to high. So no, hold on. Return 0. Hold on. Count n is that. But the DP is different. DP is always start from 0, right? So DP start from 0. And it is leading 0. The last digit is -1. Okay. Then we try to find all the way to n. Okay, makes sense. That makes sense. So we say if we go through the whole thing, then we find 1. Otherwise, I go for the next one, right? Because current is 0. And the next one what is this DP? DP is index. DP is index, right? DP is index. DP, the I is index. I plus 1. I don't understand. Tight. Max digit. D. I can go from 0 towards the current digit. For my current one, okay? Yeah, because it's smaller, right? Yeah, so for my current one, I can go through all of them. And what does tight mean? So I go through all these digits. And if it's equal to, that's a true. So tight is true. And D is not equal to max digit. So the next one is false. If tight is false, the max digit will become 9. Oh, I think I know. Max digits means, yeah, because at the start you cannot go above, right? If it's like kind of in the middle, you can. But if it's at the start, you cannot go above. Which means next tight. So the current digit is whatever it is. Then the next digit can go to 9. That is correct, right? If the current one is okay, the next one can go to whatever you want, right? Yeah. But to start, the first digit is tight. You cannot go beyond, right? So the first is tight. And and you can go to the max digit. If you hit the max digit, right, then the next one becomes tight, right? Because the current one is tight. If D is the digit for the current position, right, for the current position, if it hits the max digit, then the next one will become tight. Yes. If the current one, right, if the current one is tight, which means it fits the maximum, it already hits the ceiling, then the next one, you cannot go to 9, it has to hit the ceiling. Okay, so yes, next tight. Okay, now leading 0. If the digit is 0 and leading 0 is true, then the next one will also be leading 0. Otherwise, it's not a leading 0. So depending on whether the next one is a leading 0, if the next one is a leading 0, then the last digit does not change, right? Because it's a leading 0, so whatever the last digit is, we will use it. But if the next one is not a leading 0, if the next one is not a leading 0, if the last digit is a -1, or absolute last digit minus the current digit is equal to 1, so if that's the case, then it's still a good number, then we basically said the current one is the D is a valuable one, right? It's a valid one. So I do the next one is use my and then do that, and then we get the answer, and then we'll have the answer, and then I will. Okay, yeah, this -1 is really weird, right? It's really weird. Then we just count the high and count the low. Count the low, and we'll plus mod. I think I understand. Wow, I think this is pretty smart. This is pretty smart, I think. It avoids a lot of the edge case that I have to fight. I mean, I have a lot of edge cases I have to deal with, and it's really make it, yeah. I mean, it's fast, right? This one is fast. This one's very fast. But this is, logically it makes a lot of sense. It's kind of a, how should I put it? It's like a prefix, right? It's a prefix count. You count from 0 to high, you count from 0 to low, and then you just find the difference between the two. Now, I think the only difficult part is this max digit thing. That one requires some thought, right? That one requires some thought. Max digit. So we're finding everything, right? The number of stepping numbers start from 0 all the way to here. So basically we say, okay, if the first digit is 0, could be a leading 0, right? And what the next digit is going to be. And the next digit can be, actually no, we're saying, give me a number, right? We have a number. We want to say from 0 to how many stepping numbers are in there. So we find the first one, right? We find the first digit, and the first digit is a tight one, so we cannot go beyond that. So we have all the digits, so we can find this, right? Then what we're saying is find me from this towards the end, right? From this second, right? The second towards the end. And depending on what the previous one is, we can know if the second one is a tight one or it's not a tight one, right? So we want to see from this towards the end, how many there are, right? How many there are. And I still don't understand, right? I still don't understand. So we start with answer 0, and you're supposed to find the range is from 0 towards n. That's the thing. You have to find from 0 towards n. Are we finding from 0 towards n though? Hi. How did you find from 0 towards n? Like, is 1 counted? Because I plus 1 is just moving on to the next digit, right? It's moving from the next digit. And you're telling me dp this thing, you're telling me this thing will give me the total count. Count the number of stepping numbers in range 0 towards n. Really? How? Like seriously, how? All I guarantee is, all I guarantee is from the first position I get a small value, okay? And it's smaller, right? But what if my n is a 3-digit number, right? N is a 3-digit number, and then I start, right? I start. My current D is 1, okay? D is 1, which, matters. It's just a single value, right? Or it can be, I don't get it. I still don't get it. Like, if I pass in count high, let's say high is 1, 2, 3, okay? High is 1, 2, 3. So n is 1, 2, 3. And I start with 0, okay? So the first digit is 1, and it's tight. So the max digit is 1. So D cannot go above 1. That's bonkers, right? That's bonkers, because 1, 2, 3, I can have 1, 2, 3, 4, like single digit. I'm not sure. I don't quite understand. No, I don't understand. What the hell is this? Hold a second. I will like to run some tests on this. This is weird. I do not understand this one at all. Okay, let's reset this. But I definitely want to understand. Okay? I think it deserves understanding. def count. Okay, that's the count. Okay, let's just return count. Okay, 1, 2, 3. Give me 1, 2, 3. So what will happen? Oh, you do a self? Jesus, man, you don't need self. We just define it inside. Mod is not defined. Damn it. Ugh, mod. 1, 2, 3, 4, 5, 6, 7, 8, 9. I just want to know, like, if we do count 1, 2, 3, it give me 30. Damn, it's 30. It does count everything. Huh? How? Like, seriously, how? Like, if I do, I don't know, let's do 5. Okay, let's do 5. Which give me 6, which is 1, 2, 3, 4, 5. Wait, is 0 counted? 0 shouldn't count, right? Well, I guess it will count 0 in this case, but it's okay, right? Count 5. Okay, let's just get into it. So it'll be 5. Okay, it works because max digit is 5. So we go to 5. So D will start from 0. Okay, we start from 0. And this one will get to the end. So each one will plus 1. So we plus 6 times. Then we get 6. Okay, I agree. This is fine. How about 1, 0? Okay. 1, 0. Well, it's 1, 0. So the D is 1. Max digit is 1. So D is basically 0 and 1. Right? D is basically 0 and 1. And hi. And D is 0 and 1. So D starts with 0. And next one's not tight, but it's still leading. Oh, it's this. This is the magic. The leading 0. Leading 0 is the magic, right? Yeah, leading 0 is the magic. You can have a giant number, right? But we say at each position, you can do a leading 0, right? You can do a leading 0 for the next one, right? For the next one, you can have, yeah, because the current D is equal to 0, and the next one can be a leading 0. Because of that, we basically ignore everything to the left, right? We start one from I plus 1. We start from there, and it's a non-tight, right? It's not a tight one, so we can go from wow, that's true, because you have if it's a smaller number of digits, then it will always be a non-tight. It will only be tight if your current one is the max digit. Otherwise, it will be a non-tight. It will be a non-tight. Yeah, whenever it's a non-tight, you go to the next one. So you're basically starting from, 0 all the way to 9. Right? You're starting from 0 all the way to 9. Because it's non-tight. That's how you do. Yeah, basically you start from the first digit, right? And then if you want to match the first digit, and it has to be like the same, then if the first digit you get a smaller value, right, then you can go with the next digit is non-tight, right? You can basically go from 0 to 9, right? You can go from 0 to 9. And then you have the second one until you have a 0. The first one is a 0, which is a leading 0. So we can go to the next one, that is a leading 0. So that's when you get a smaller number of digits. Oh, this method is too good. Oh my god, this is a great method. Holy crap. How did you think of this? Amazing. Really? I don't think so. Oh, that's amazing. Amazing. This is amazing. All right, let's to come back to this tomorrow. Need to come back to this tomorrow. Wow, this is some amazing solution. That DP thing, jeez, it's beautiful. This is beautiful. Holy crap. This is beautiful. This is so good. We have to try it ourselves. We have to try it ourselves. This is no way. I cannot let this pass. This is way too good. Man. This concept of is tight. And the concept of leading 0 is really... I mean, the leading 0 basically just the previous digit, right? If the previous digit is -1, then it's a leading 0. And yeah, previous digits. You have the idea, you have the concept of previous digit, the index. And there are so many concepts in this DP itself. There's so many concepts. Wow. But the most important insight is if you want to find the count of anything in between a range, one way to do it is to find a count from 0, from the lowest towards the current and the lowest towards the other end, and then you find the difference between the two. Then you get the count in between the two. That is a great insight. That is also great insight. So it's like 3 or 4 amazing insights in this solution alone. I cannot help it. Let's do it tomorrow. Yeah, I have to do it tomorrow. It's too good. All right, I'll see you guys tomorrow, and we will write this amazing solution. Adios.